In this video, I'm going to go over a few of the problems that are on your 9 weeks review targeted towards your final exam, which will be this Wednesday, I believe. Okay, so for this first problem, I chose number 13, and this is just a simple cross multiplication problem. So we have 4x times 7 is equal to 2x minus 3 times 2. Okay, so I'm going to go ahead and multiply that. So let's do 7 parentheses 4x. That is, this piece right here is equal to 2 times all this. 2 parentheses 2x minus 3. Okay, so this is a simple algebraic problem. We're going to distribute here. 7 times 4 is 28, brings out the x that goes with it. And then we have 2 times 2x, so that's going to be 4x. And then 2 times negative 3 is negative 6. And now we have a simple two-step algebraic equation. So I'm going to go ahead and move all the x's to one side. So let's do minus 4x here, minus 4x here. That gets rid of this because we have 0 there. 28 minus 4 is going to give me 24x equals, bring down that negative 6. And my final step here is to get the x by itself. So that means in this case that I need to divide by 24. Remember that when we are doing this last step of division, you always divide by the number that is next to the x, okay? That comes out to 1, so I can cross it out. So x is equal to negative 6 over 24. If we can simplify it, we do. In this case, you can see that both 6 and 24 are divisible by 6. So this simplifies to negative 1 over 4. So x is equal to negative 1/4 in this problem. Okay. Next one I'm going to go over is number 14. This one is asking you, I believe, to give the equation of some problem. Okay. And I believe in this case f of x is equal to x cubed. So you have this at the top. F of x equals x to the third power. And we're just applying a transformation to it. So if I apply x minus 3 to it, I'm going to end up with something like this. Y equals parentheses cubed. So this x right here, use different color. So this x is this parentheses right here. And what I'm doing is I'm going to plug in this piece into there. So I have x minus 3 in here. So this is the equation. The x-intercept for this, it should be pretty plain to see, but if not, you can always go with what we used to do here. So for x-intercept, remember that we have to set y equal to 0 because on the graph, wherever y is equal to 0, that's where we have x-intercept. So if I do that, if I plug a 0 into the y right here, I get 0 equals parentheses x minus 3 cubed. And then I solve for x. So to get rid of that cubed, I cube root. And that leaves me with 0 on this side because the cube root of 0 is just 0. This cancels out, so I'm left with x minus 3. I add 3 to both sides. And it turns out that x is equal to 0 plus 3 is just 3. So in this case, my x-intercept is just 3, 0. Which also happens to be the inflection point of this graph right here, because this right here, the inflection point is 3, 0. Remember, opposite, same. So opposite of negative 3 is positive 3. There's nothing over here, so the y is a 0. So this is the same as the x-intercept. As far as transformations go, on the graph, if you were to graph this, I would have, let's see, 1, 2, 3, my point right here, and this is a cubic function, so that means that the graph goes something like this. So as far as transformations go, from the center, I went over 3 to the right. So I'm going to go ahead and write 3 right, the horizontal shift, okay? And that's it for that part. The second part is asking you for the inverse equation. So this one might require a little bit of work. You're going to do the whole switch x and y thing. So this is my equation right here. So I'm going to go ahead and write it out. Y equals x minus 3 cubed. And I'm going to find the inverse of this. So to do that, I have to take the y and the x and I have to switch them. So then I have x equals y minus 3 cubed. Okay, and we're going to solve for y. So just like I did with finding the intercept over here, I first have to get rid of this little 3 here. To get rid of a cubic, we cube root. So cube root over here, cube root over here, and that will get rid of the cube for me here. So I'm left with the cube root of x is equal to y minus 3. And of course, I'm trying to get the y by itself, so I'm going to go ahead and add 3 to both sides. And that will get rid of the 3 over here. So my final answer here is going to look something like this. Y equals the cube root of x, and then space, so space plus 3. And because this is the inverse, you have to label this either as negative y to the negative 1, or we can go ahead and do f of inverse, however you want to do it. But this right here is the important part, okay? So let's go ahead and label it as f of inverse just because that's what I have here. So f of inverse of x is equal to the cube root of x space plus 3. And if you look at the two equations, they're kind of the opposite. So this one has everything on the inside of the parentheses. This one has the 3 on the outside of the root, okay? And if you want to be a little more technical, this f of inverse is probably better if I do y inverse, but we're not being too picky right now, okay? Last part for this, they're asking you for the y-intercept. So for the y-intercept, we are looking for where this one, so this one, crosses the y-axis. If you remember, a long time ago, we did talk about this. Pretty much because these two are inverses, so these two right here are inverses of each other, that means that the x-intercept is the inverse of the y-intercept. So this is the inverse of this one. That means that if my x-intercept is 3, 0, the y-intercept is 0, 3. And that makes our life so much easier so that we don't have to do all the work again. Okay? Next problem. Problem number 21. This one is to simplify and give the domain. So in this problem, we have trinomials, we have GCD problems, and we have a division. So we're going to have to do several things. The first thing I would recommend is to factor everything. So I'm going to go ahead and do that in the first step. I'm going to factor this one first, and I'll kind of label it by color. So I'm going to factor this top part first. Here I have two parentheses, and I have m's in this case. And because it's a trinomial, I can see that I'm probably going to have to do some kind of trinomial factoring where it's put into two different binomials, okay? So I'm looking for two numbers that multiply, so multiply to negative 20 and add to negative 1, okay? So they add up to this middle one and they multiply to this one. Well, I know that 5 minus 4 is going to give me a 1 somehow, so I could probably use 5 and 4. Since this is negative, one of these have to be negative. It looks like the bigger one's going to have to be negative because my middle number, negative 1, is negative. So let's do negative 5 and positive 4. And let's see, negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So that works out. So there is the first part. I'm going to go ahead and look at the denominator of this one now. So now I'm doing this one. And this one only has two terms. And the last term is not a perfect square. So I'm probably going to use GCD for this one. So if we look at it, they both have m's. They only the first one has a 2. So we probably can't take out any kind of number divisible by 2. We could, however, take an m out. So I'm going to try taking out an m. When I say take out an m, what I'm actually doing is I'm dividing this piece right here and this piece by an m. So if I divide these pieces by m's, I'm left here with a 2 and an m. M over m on this side gives me a 1, so plus 1. And that takes care of this one and this one. Okay. Next, I'm going to go ahead and flip change the next part. So because this is division, we kind of have to remember that keep flip change rule that we like to use. Not the chicken, the rule we used for 8th grade, I believe. Keep flip change. We keep the first fraction, we flip the second fraction, and we change this to multiplication. So now I have the times right here, okay? And I'm going to go ahead and rewrite these ones, but I'm going to put them in the other spots. So this one I'm going to put on the top, 2m squared plus 9m plus 4 all over 5 minus m. Quick note on this, I did change this one. This one on your paper, you have it as a plus, but it should be a minus, okay? So make sure that we change the positive, I guess I could say, to a negative, and that's just a typo. So please make that change. I'll probably announce it in class, but either way, if you don't catch it, hopefully you catch it here. Okay, this should be 5 minus m. Okay. Anyway, so now this right here is the proper location of every term. So now we're going to go ahead and factor the next part. We're going to factor this piece right here. So let's do an arrow instead. We're going to factor this right here, and we're going to factor the bottom as well. For the top, I'm going to go ahead and do some side work for this one. We know that it's trinomial because there are 1, 2, 3 terms. So it's probably going to be a trinomial factoring problem. This one is tricky because we have a leading coefficient that's not equal to 1, which means that this number is not a 1. Okay, so we kind of have to play around with the numbers a bit here. I know for sure that I have a 2m and an m because the only multiples of 2, so the only multiples of this one are 2 times 1. So I have to have a 2 and a 1 somehow, okay? Well, we don't usually write that 1, so it's already implied. The next part I have to figure out is what numbers are going to go here and here to give me this factor of 4 that also add up to 9. So I believe I did this in class, but I can do it here again. I know that 4 is the same as 1 times 4 or 2 times 2. So I can try out some of these numbers. I can say, well, what if I put a plus 2 here and a plus 2 here? If I were to FOIL this, so multiply it, I need to add up to that 9 in the middle, okay? So I'm going to try that out. If I did the inside and the outside, because that's the inside and the outside, this right here, is what gives me this middle number, okay? So 2m times 2 would give me 4m, and then 2m would give me, well, 2m. And if I add this, this gives me 6m, which is not equal to 9m. So this one is not going to work, okay? So that means that I need to change these numbers here, okay? So let's try another pair. So 2 and 2 don't work. Oh, different one. 2 and 2 don't work. Okay, there was a 2 there, a 2 there. So let's try 1 and 4. So 1 and 4. Let's see. 2 times 4 is 8. Bring down the m. 1 times m is 1m. If I add them up, I get 9m. And that's exactly what I want. So that means that these factors are good. This is what I want to use. Okay? So rewriting this, I'm going to go ahead and rewrite this. I would have all of this times parentheses 2m plus 1 parentheses m plus 4. And I'm just going to copy this whole thing all over again. And I know this is a long problem, so just bear with me. It will be over soon. M minus 5, m plus 4. I'm just copying what I have up here. And on the bottom I have m times 2m plus 1. Okay, and the last thing I'm going to be looking at for this problem finally is this 5 minus m. Okay, so 5 minus m, we learned a cool trick with this. Just quickly a quick reminder, I know that if I take a negative 1 out of here, so if I divide the 5 and the m by negative 1, the signs change. So I would have negative 5 plus m. But of course, this is the same as m minus 5. Pretty much I'm taking the m and I'm putting it first. I'm taking negative 5 and putting it second. So this is the same. This right here is the same as negative 1 times m minus 5. So I'm going to replace this one with this right here. So negative 1 parentheses m minus 5. Okay. So what I'm looking at now, finally at the end, is this right here. And I'm just going to kind of box it up. It's not the final answer, but I want you to see what we have left over. Okay. Whatever we have on top that is the same as the bottom can be crossed out because that's equal to 1. So if we look at that, I have 2m plus 1 here and 2m plus 1 there. So those are gone. I also have m minus 5 here and m minus 5 right here. Okay, so with that in mind, I'm left with m plus 4 right here, and there's a parentheses there, another m plus 4 over here, and m over here. So some of you might want to cross out this m plus 4, but because they're both on the top, we cannot do that. We have to leave them. So I'm going to go ahead and kind of circle everything that's left over. I have m plus 4, m plus 4, and m, and we also have this negative 1. So my final answer will look something like this. M plus 4, parentheses, m plus 4, over, and then I have this m and this negative 1. So I'm going to go ahead and just put the m. And what we can do with negative 1s, I mean, we could put it down here, but typically we like to put those negatives in the front. So we can leave the negative right there in the front. And this right here, after all this work, is our final answer. Okay? If you wanted to go a little bit further, you could FOIL this piece right here, but I'm not going to make you do that, so you can leave it like this. Okay? Moving on. We got 2 more to go. We have this problem. Okay? This problem is one of the more difficult problems that we have. Of course, on your exam, you can probably just plug in numbers and see what works. But I'm going to go ahead and show you the actual math behind this, and hopefully you can try this method as well, a little more algebraic based. Okay, so in this problem we're trying to solve for x. What we want to do is get all the x's on the same side. We also want to try to get rid of this cube root because it kind of throws things off for us here. Remember that the opposite of cube root of x, so the inverse of this, is that little 3, the cube. So we're going to go ahead and cube everything first. So I put a parentheses cubed, parentheses cubed. And what that does is it crosses this out for me. And on this side, this means that I'm going to have 3 of these parentheses. So let me rewrite it first. This is x plus 3 cubed is equal to x cubed plus 27. So you're saying, now what do I do? Okay, well, this is where the crazy algebra comes in. This little 3 right here means I have to have 3 of these parentheses. So this means I'm going to have x plus 3, there's 1, x plus 3, there's 2, and x plus 3, there is 3. So 3 means 1, 2, 3 of these, okay, equal to all this over here, x cubed plus 27. And so now, just like I did in a long time ago, past video, I'm going to multiply these binomials right here. Okay, I'm going to start with just 2 of them, and then I'll figure out the last part. So multiplying these first two, I would have x times x is x squared. X times 3 is plus 6x. Then I do the inside. 3 times x is plus 3x. And 3 times 3 is positive 9. Combining all of this gives me x squared plus 6x plus 3x is 9x. Oh, wait a minute. Did I mess up somewhere? Let's see. Oh, I got ahead of myself here. 1 second. Let's try that again. Sorry about that, guys. It's kind of late right now, so we have x times x is x squared. Okay, x times 3 is positive 3x. There we go. Then we do the inside. 3 times x is also 3x. And 3 times 3 is positive 9. There we go. Okay, so combining all this, I get that x squared plus 3 is 6. That's where I got that 6 from earlier. I was getting ahead of myself. Plus the 9. Okay, so we have all that just from these two right here. Okay, I'm going to go ahead and bring this one down, and I'm going to multiply that one next. And this is where, if you make little mistakes like I almost did right now, we kind of get a little bit lost. So we're going to go ahead and multiply this now. So I'm going to go ahead and go this way now just because I like to do the one that has the least terms first. So x times x squared is x cubed. X times 6x is plus 6x squared. X times 9 is plus 9x. Now I'm going to take care of the 3. So I'm going to do 3 times x squared, which is plus 3x squared. 3 times 6x, which is plus 18x. And 3 times 9, which is plus 27. And all this is equal to this over here. So far, this was just equal to all this right here. So x cubed plus 27. A lot of work, a lot of multiplying. Okay, easy to make mistakes, so be real careful. You don't want to mess up like I did. And if you do, go back and fix it. Not a big deal. So a couple things you should notice here. We should notice that both of the sides have an x cubed, and both sides also have a 27. Whenever we have the same term on both sides, they kind of cancel each other out, because if I were to move that x cubed, I would do minus x cubed, so it would just zero this one out. Same with the 27. So I can cross all this out. And that means I'm left with whatever's left over. So in this case, let's see. On this side, I have nothing. I have a 0. Okay. On this side, let's say I have 6x squared here. I also have a 3x squared right here. So I'm going to start with those two because they're like terms. 6 plus 3 is 9, so 9x squared. And then I have a 9x and an 18x, and 9 plus 18 is 27, so plus 27x. So this is the equation I have left, which is a lot easier to deal with. So let me rewrite that just so it looks a little bit nicer. 9x squared plus 27x is equal to 0. When you're at this point, because we have a square, we want to try to factor to get the final answers. If you haven't given up on me yet, because I know this is a long problem. So we're going to factor. In this case, it looks like we're going to factor using GCD. So I can take out from here, I can take out a 9. So let's put a 9 in the front. And I can also take out an x because they both have at least one x. So if I divide 9x squared, and I'm going to do the side work over here just so you can see what I'm doing. If I divide this by this, I'm left with x. So x goes in the parentheses. And then if I divide 27x by 9x, I'm left with a 3. So plus 3. And this is all equal to 0. Okay? So when we're left at this point, we're almost done. What I'm going to do now is I'm going to take each of these. So I'm going to take this and set it equal to 0. And I'm going to take this and set it equal to 0. I noticed that on another problem earlier this week, this one confused people. So let me go over this one in detail. We have 9x is equal to 0. When we are solving that, we will divide both sides by 9. Okay, so we're left with x is equal to 0 divided by anything is still going to be 0. So this one is just 0. Okay, the other one you've already dealt with, so this one shouldn't be too difficult. We subtract 3 from both sides, and we get x is equal to negative 3. So this is the other solution. After this, you would go ahead and check them. For this review, I will go ahead and not make you check them, if that makes any sense, just because of the time. So trust me when I say that both of these work out. And so my solution set for this, okay, will be that curly brace, negative 3, comma 0. Okay, quick recap. So we cube both sides, okay, to get rid of that cube root. Once I cube them, I have to expand here, expand and multiply, which is what I did here. Okay, this is just multiplying binomials. We multiply everything out. When we get to this point right here, we can cross things out because we have the same thing on both sides. We had that x cubed and the 27. Okay, and then we just combined like terms, which gave us this line. So we combined here, and then we just factored. After factoring, we solved, and we ended up with our 2 answers. Okay, let's see, how are we doing on time so far? Okay, one more really quick, last problem. So for this one, this is actually a lot simpler than the one we just did. We have a cube root equation. So we're just going to go ahead and cube both sides because we don't have anything else on this side. So we can go ahead and do that right off the bat. That will get rid of this from me here. I'm left with 2x minus 9 is equal to negative 3 cubed is the same as negative 3 times negative 3 times negative 3. So that is just going to be, let's see, negative 3 times negative 3 is 9. And then 9 times negative 3 is negative 27. Bring everything else down. We add 9 to both sides. These cross out. So I have 2x is equal to negative 27 plus 9 is going to give me negative 18. Divide both sides by 2. And so x is just equal to negative 9. And if we were to check that, 2 times negative 9, negative 18, minus 9, negative 27. The cube root of negative 27 is negative 3. So that's it. Those are the, let's see, 1, 2, 3, 4, 5 problems that I've given you. Okay. Hopefully you can finish the rest. If you have any questions, go ahead and you can comment on the Google Classroom and I will get back to you as soon as I can. That is it for this video.